All right, our topic today is permutations. We have a couple learning goals to go with that. The word itself is new for some of you, but we're going to be able to solve problems including linear permutations of distinct or indistinguishable objects, solve problems including circular permutations. So we're going to deal with both linear and circular. We'll review a couple notations along the way as well. So let's get started. Things we need to know. When we say permutation, it's an arrangement of objects in a specific order. Linear permutations, we're thinking in a row, like a list. Factorials we've seen before, remember, are n positive integers such that n factorial would represent that number times the next consecutive decreasing integer times the next consecutive decreasing after that, all the way down to times 3 times 2 times 1. Okay? And 0 factorial is defined to be the value of 1. So knowing that, the number of permutations of n objects is given by n factorial, the number of ways 3 things can be arranged would be 3 factorial, which is 3 times 2 times 1. So that's your definition of how we start. So now, looking at our baseball situation, on a baseball team, 9 players are designated as the starting lineup. How many different starting lineups are there possible? Now, some people would say, well, we need to know how many people. No. They're just talking about the 9 players. So if you took 9 players at random, and they're designated as the starting lineup, how many different lineups, like on the lineup card? So down here you can see we have a lineup card, an example of a lineup card. So how many, dealing with 1, 2, 3, 4, 5, 6, 7, 8, 9, how many ways can we actually put those 9 players on the lineup card? Who's going to bat first, second, third, fourth, fifth, etc.? Okay. So as we do that, you got to start thinking, well, wait a minute, that's an arrangement in a specific order. 9 things. And most of you would say, well, wait a minute. If I got 9 guys that could be in that first slot, once I fill it in, now there's 8, then there's 7, and you get the pattern all the way down to times by 2 times by 1, better known as what? 9 factorial. So good job on the situation or the listing of it. And when you do your math, go ahead, either multiplying it out or using your factorial key. Did you get 362,880 total possible combinations? Wow, that's a lot of ways you can arrange 9 people in 9 slots. All right, reset that, and here we go. Next situation. What you need to know here is that permutations of n objects take an r at a time. Some of you are going to say, well, wait a minute, isn't this like combinations? But remember, permutations, order matters. So the notation is going to be very similar. So look up top. You see it'll say P n comma r, or it'll say NPR, just like our NCR when we did combinations. And then there is a formula that says all permutations are n factorial divided by n minus r factorial. Now, realize that we just did an example of a permutation of n by n. If we have 9 players and we're going to put them in 9 slots, that would have been the same as 9 things taken 9 at a time in specific, and that's why it came out to 9 factorial. Now, if we don't take all of them, then we have to use our little formula. So our example here is find the number of ways to listen to 3 different CDs from a selection of 5 CDs. So I believe if we use our NPR notation, we have 5 things in a permutation, which is a specific order arrangement, and we're going to take 3 of them. So 3 different CDs from a selection of 5. How many ways can I choose 3 from that 5? So n objects, take an r at a time, choose 3. If we follow the setup, then we've got n factorial, which is 5 factorial, over n minus r, and again 5 minus 3 leaves us with 2 factorial. Now keep in mind what we did with combinations. We said if we could write 5 times 4 right on down using this denominator factorial as our guide, we would put a 2 factorial up top, but we'd still need the 3, the 4, and then the 2 factorial goes right on down. From there, we can do other combinations. Now, what that means is now we can cancel, and 5 times 4 is 20, 20 times 3, 60. We should get an answer of 60. Let's double check if that's what they got. Wow, 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 wow. We got the whole thing there, and it looks like 5 times 4 times 3 times 2 times 1. Looks like the work isn't finished here, actually, because we don't even have an answer. So if we finished that as our work, so there's the 5, 4, 3, 2, 1. Then it's a 2 times 1 if we're doing that. The 1 and 1 cancel. The 2 and 2 will cancel. 5 times 4 is 20. Times 3 is 60, which is exactly what we just got. So good job. Next one. Now, if we're dealing with circular permutations, you got to remember that n distinct objects are arranged around a circle. Then there are n minus 1 factorial circular permutations of n objects. Okay? In how many different ways can 12 students attending a seminar be arranged in a circular seating pattern? Okay, we got 12 of them. 12 minus 1 is 11. 11 factorial. 11 factorial. Instead of multiplying by hand, we would probably just use our calculator, factorial button. Is that what you did? Wow, look at that. With 12 people, we would get 39,916,800 different combinations of those 12 people. Wow. Another fact we need to know, permutations with identical objects. If you have several things that you're arranging and the number of distinct permutations of those n objects with r identical objects is given by n factorial divided by r factorial, where that r could be anything greater than 1. So if I have 2 things that are identical, 3 things that are identical. So r sub 1 is identical. If you have a second thing that's identical, we'd call it r sub 2. If a third thing, r sub 3. So if you have more than one identical thing, you can see here that it's n factorial divided by r factorial. And each time you have a repeating value or identical object with its number of, then you have to use it in your math. Okay, so how many of those identical objects? So here's an example. Ronald is organizing sports equipment in the physical education storage room. He has 15 balls that he must place in a line. In how many ways can he line up 6 footballs, 2 soccer balls, 4 kickballs, and 3 basketballs? And so you can see we have that combination listed down here in our work. So start thinking again, n factorial over r factorial. N is how many total? So that would be the 15. Whoops. Let's reset that. N would be the 15. But now start thinking, wait a minute, we have 4 different kinds of balls here with each of them in a different quantity. So we have 6 footballs. We have 2 soccer balls, repetitive. 4 kickballs, and 3 basketballs. So if we set up that as our thinking or our work, and again, you'd almost have them, if you were doing an arrangement, you'd have to call them football 1, football 2, football 3, football 4, football 5, football 6, so you knew about what one was going in which slot if they asked you to write the combinations. But go ahead and do that math. And we should be looking at, oh yeah, it's sort of in the way there, but 6,306,300. And I was thinking I was trying to pull it away, but that'll even be better. Wow, it's exactly the combination we had. So the number, quantity of the balls, divided by each different type of ball with its repetitive value in a factorial. All right, so we've given you a couple different combinations: circles, linear, permutations with repetitive values, all little shortcuts, and you will use those in our section on permutations. Remember, arrangements of objects in a specific order. Bring any questions you might have to class.